For today's adventure, you're going to need an Arduino, a cable to power the Arduino, a power supply for the Arduino. As you can see, it's got USB on it. Two relay switches. And you can see it doesn't really require too much power. Two ultrasound devices. A roomba. And a butt ton of cables. Okay, so the first step is to remove most of these screws at the bottom of the Roomba. And watch out for these tricky ones in these nooks. So if you look closely, you'll see that on the motor are, I guess, 6 cables, with 2 of them being thicker cables, which are the power cables. And so one of those is what we're going to be clipping and attaching to our relay. So now that you have extended those cables, and I also cut a hole in the thing so the cables can actually come out, and I have that for both sides. Then you can close this back up because, I mean, unless you want to be super fancy, everything else is just going to be kind of duct tape on top or, fastened in some way. Okay, so this might be one of those moments where I probably should make a wiring diagram. Right now I'm powering it just from a regular power bank. There's the Roomba, I haven't put everything on there yet. There's the Arduino, and the power cable, and a bunch of cables coming out of the Arduino, and then going to the ultrasounds and the relays. But basically, what it is, first of all, everything needs 5 volts, so that's all for, the relays need 5 volts to be able to move the magnets inside that box of solenoids, and the sensors need 5 volts in order to work. And so that's where a lot of this mess comes from, is I just kind of kept chaining these Y intersections so that everything had 5 volts. And they all need grounds. Fortunately there's 2 grounds, so I didn't have to chain as many things on those. And then, okay, so you've got the ultrasounds, which want a 5 volt and a ground, one on each side. And then you've got the purple and the green, which are your trigger and echo. And those just go to digital, so I've got purple and green, and then I've got 2 more purple and greens for the other ultrasound. I put some tape on it so that I know which relay it goes to, or, it's paired to, I guess you could say. So if I zoom out a bit, it's like, hey, look. You're seeing the other guy turn on because it's over there. Has that satisfying click. Anyways, then the relays have 3 guys to them, and they basically just need 5 volts, they need ground, and they need a digital signal. And so I've got, that's kind of that order, and then I've got one of the relays set to digital 9 and the other one set to digital 10. And there's really only 2 ways to do this, so, and especially if you put tape, then it kind of fixes itself. And now all we really have to do is attach it to the Roomba and try it out. One thing I forgot to mention is that on the relay side, on the Roomba side, we want to connect to the no and the common. I forgot what no stands for. But yeah, basically those top 2, the NO and the COM. And the way it's set up is that it's going to be open, or sorry, well, closed, like the circuit's going to be closed so that those 2 are connected to each other all of the time, unless something gets too close to the ultrasound, in which case it's going to, unhook them from each other, and that should cut the engine, the motors. So once it's running, it looks like this. Here's the code for the ultrasonic sensors on the Roomba. Basically, you start out with just kind of, claiming all the pins, and you're going to see I basically just did one and then copied and pasted it for the second guy. So you got, your ping pin, your echo pin, and then your relay pin for each one of the, I just put a 2 next to the other one for each one of the sensors, really the sides. And these are all the digitals. And then, you've got your regular setup and loop. During the setup, I'm going to be like, hey, I'm going to be using these relay pins as outputs and just start them up as high because I want the Roomba to be able to control the motors by default. And then I got some serial for debugging. And then we got the loop where we declare our things. I think I probably could have put that in the setup, but anyways, this part. Then we got the setting up the pin modes. This is basically your code for your regular ultrasound code right here, where first we tell her we're going to be doing a pin output. This probably could have gone up there too, but works anyways because it's C. So we set it to low, we wait a little bit, then we set it to high and we delay a little bit, and so like that's the actual ping right here. Low, high, low. And then we start listening to the echo pin, and then there's this magical function here, pulse in, which measures the length of the response, and then that's kind of proportional to how long it took to, maybe even exactly how long it took to get the time back. But anyways, we got that in microseconds. And then there's this function down bottom that's called microseconds to inches and microseconds to centimeters, and you're basically just estimating the speed of the speed of sound and then how long that would have taken, which the speed of sound is 343 meters per second. I think that's at a standard temperature and pressure. And then there's some serial prints for debugging, and then I threw in some quick, like, hey, if inches is less than 10, then cut the relay so it can't control the motors anymore. Otherwise, keep it going. And then there's a short delay. I'm not sure that's necessary here, probably later on. But then I basically do the exact same thing for the left side, or the other side, and they just kind of switch back and forth, and it happens fast enough that compared to the speed of the Roomba, that doesn't become an issue. And that's about it. And then you've got your microseconds to inches where you do some math, and microseconds to centimeters where you do some math.